Alright, now look at this question. As shown in figure 3, 1.34 kilogram ball is connected by means of two massless strings to a vertical rotating rod. The strings are tied to the rod and are stretched. The tension in the upper string is 35 Newton. Okay, draw free body diagram. Okay, calculate the tension in the lower string. Calculate the net force on the ball and calculate the speed of the ball. Good. Okay, first of all, question A asks for free body diagram. Okay, we need to draw a free body diagram. Okay, hold on a second. Okay, so that's better. Yeah, I make it bigger. So I want a free body diagram for this ball. Okay, our target is the ball actually. Yeah. So our target is the ball. Maybe you can draw just a line, you know. Our target is this one. Okay. So first of all, identify what kind of forces acting on the ball. Okay. So what are the forces acting on the ball? So it is connected with two string, right? Connected with two string. So it must have tension, and the string only pulls. Yeah, only pulls, never pushes an object. So it only pulls, so away from object. Yeah, this string, the tension must be away from object. The string always pull. So so at the top, this one, sorry, let me draw it better. Yeah, like this. Yeah, so here there is a tension 1. We'll put as the upper string as tension 1, and then below here also have another tension. String only pulls, okay, away from object. And then the ball also has mass. We put as W. Okay. Does it have any normal force? No, because it's not in contact with any surface. So yeah, I think that's it. Yeah, no friction also. Okay. So what I can say is this ball is actually rotating. It's actually rotating around here. It's rotating this. This is the circle the ball makes. Yeah, the circle. So, and this is the center of circle over here, center of circle. And this is the what is this? That is the radius of the circle. Later we need to find that radius also. Okay. Okay, let us draw the free body diagram first. Free body diagram only have one dot, one point to represent the ball. Okay, so let us draw it out. Okay, question A. So I want a free body diagram. Okay, now, okay, let's look at now. Now this is the point mass to represent the ball. Okay, just a point mass. Don't draw the ball. So it has the tension 1. Okay, tension 1 in this direction. This is the tension 1, and I think I don't use the red color. Hold on a second. So better use green. Yeah, maybe. So this yeah. So this is the tension 1. Tension 1, and then you have tension 2. This is the tension 2, and then you have the weight. Yeah, you have the weight going downward. Okay. What else? You have the angle theta. Yeah. Okay. But we don't know what's the angle theta. Okay. Never mind. Later we will find out. And then the center of circle is over here at the left hand side of the ball. At the left hand side of the ball. So the acceleration, we need to draw acceleration also. Yeah, towards the centripetal acceleration always directed towards the center of circle. So it's to the left. To the left. This is the centripetal acceleration. Okay, let's draw our centripetal acceleration because our center is at over here, this side. This is our center of circle. Okay, so our centripetal acceleration is this direction. This is our AC. Understand? This is our AC towards the center of circle. Okay. I think that's it. Okay, and then we need to find out the angle. So yeah, we need to find out the angle for T1 and T2 so that we can. Okay, we need to find out this angle also because we want to resolve vector later on. We need to find out this angle. So what should be this angle? Okay, maybe okay. If you look at here, this is actually a same side. Yeah, this triangle is all same side. Yeah, so it's like I can draw up here is a triangle with the same side. Okay, they all have the same side. Same side of what? Of 1.7. 1.7 meter. It's 1.7. Yeah, 1.7 meter. All same side. So we can say this all is a 60 degree, isn't it? All of this 60 degree. Okay, it is 60 degree, 60, 60. Okay, so now this 60 here is also 60. Okay, all 60 degree. Okay, just want to make it bigger so you can see clearer. Yeah, so this is okay, yeah, so this is 60 degree, right? This side, because all same side. This is the same side triangle, so this is 60 degree. So divide by 2. Yeah, divide by 2. Divide into half. So this should be 30 degree. This should be 30 degree, 30 degree. Okay, that's the angle. We got it. Now we already draw the free body diagram. Label it. This one is x-axis and this is the y-axis. Okay, now let's do the part B. Find the tension in the lower string. Okay, tension in the lower string T2. T1 we already have. It is 35 Newton. Here already mentioned T1. So we put that as 35 Newton at the top. Okay, 35 Newton. We don't have T2. Okay, what is the weight here? Weight here is mg. Yeah, mg is 1.34 times gravity. Okay. So now let's do it. Let's find the tension in the lower string. So what we can do is we do two components. We do x and y components. So do x and y components. Okay. So now let's do it. Yeah. So just want to okay. Now what's the formula in x component? Still remember? This one, at the x component we have acceleration. When we have acceleration, we use Newton's second law. Total Fx equal to ma. This acceleration is special, is centripetal acceleration, so it's AC. It's also the centripetal force actually. Okay. When for Newton's second law, we always compare with acceleration. The forces that same direction with acceleration is positive. Put as positive. Opposite acceleration is negative. Okay. And then for y component, no acceleration, isn't it? Y component, no acceleration. We just put total Fy equal to 0. Total Fy is 0. Okay. Because no acceleration, so y component is equilibrium. The s component got acceleration, so we have resultant force. So the resultant force is in x component. Y component, no resultant force. Yeah. Okay. So now we need to resolve our force. Resolve it to the T1 and T2 into x and y component. So okay. So let us resolve. Yeah. Let us resolve. Okay, yeah. Let us resolve. Yeah. So okay. So you have here. You have two components for x and y. Okay. Okay. This one. All right. So how? So let us write it down here. Yeah. Okay. Let me make some adjustment. Okay. So the x component for T1, it should be cosine 30 because adjacent to 30. So it's actually T1 cosine 30. Okay? Cos T1 cosine 30. How about y component? Y component is opposite to angle, so it's sine 30. So it's T1 sine 30. T1 sine 30. How about the T2? Okay, T2 we also resolve into two components. Okay, T2 also resolve into two components. Okay. Okay. So what's the x component for T2? X component for T2 is T2 cosine 30 also. T2 cosine 30. Because adjacent to angle. How about the y component? Y component is opposite to angle, so it's a T2 sine 30. Okay, so done. So now we can build equation already. Okay, we can build equation. So okay, look at the x component. X component we always compare with acceleration because we have acceleration. We must compare with acceleration. Forces that are same direction with acceleration is positive. So seems that in x component we have T1 cos 30 and T2 cos 30. Only these two forces, isn't it? And these two forces, they are same direction with acceleration. So both of them are positive. Both of them are positive. Okay. Equal to MAC. That's it. Okay, that's it. And how about the y component? Y component, there's no acceleration, right? No acceleration, so we just put going up positive, going down negative. Just put going up positive, going down negative. Later on, they will cancel each other, become 0. Okay? No acceleration to compare. So, okay, so T1 sine 30 is positive. And then T2 sine 30 and the mg is negative. Okay, negative T2 sine 30 and minus the mg equal to 0. Okay, now let us substitute the value. Let us substitute the value. T1 is 35. Let us substitute the value. T1 is 35. Okay, cosine 30 plus T2 cosine 30 equal to, what is the mass? Mass is 1.34 AC. Okay, and then, okay. Alright, and then here, let's continue also. Here, 35 sine 30 minus T2 sine 30 minus, this is 1.34 G, okay, equal to 0. Okay, look at the question. The question asks for what? Tension in the lower string. So we want to find tension in the lower string. Okay, so here we can find the tension in the lower string from the y component. Look at here. If the x component, we still cannot find tension, the T2. Yeah. The question for this B is you want to find T2. But if you look at the x component, you cannot find T2 because you need to find you don't know the AC yet. Yeah, the AC. Actually, the AC is V squared over R. But we don't have, it's not provided the V, isn't it? Yeah, V is not provided. So we cannot find AC, we cannot find T2 from the x component. Cannot find T2 from the x component. We have to find from y component. Y component, yes, you can find T2. You see that? There is a T2 over here, and all the other values is already known. So yeah, G is 9.81. Yeah, G is just substitute 9.81, and you can find T2. Let's calculate the T2 now. Okay, Okay, so we got the answer, yeah? The T2 is actually 8.71 Newton. That's the answer, 8.71 Newton. Is it correct? What's the T2? Yes, 8.74 Newton. It's almost the same lah. Okay, so it's correct. Our T2 is correct. 8.71. I got 8.71. Okay, yeah, it's correct. All right, that's the T2. We got the T2 already. Now we want to find what? What's the net force? The question asks for net force on the ball. Okay, this is interesting. Net force is also called the resultant force. It's also called the resultant force. This one, back to the concept. What is the resultant force for a circular motion? The resultant force is actually the centripetal force. The resultant force is actually the centripetal force. Okay, which you know, because we know resultant force is what? The Newton's second law. So resultant force or the net force is ma, isn't it? Total force is ma. So maybe let me change it. Resultant force is ma, but in our case here, circular motion is the A is AC, centripetal acceleration. That's why for this net resultant force, which is equal to mac, we have a special name for this resultant force. We call it the centripetal force. We call it the centripetal force. Okay. So what is actually centripetal force? It is actually the resultant force towards the center of the circle from all the existing forces available on the ball. Its centripetal force is actually resultant force. Do you know that? Do you realize that? Centripetal force is actually resultant force. It is actually the resultant force. It's not another new force. It is actually the resultant force from existing force. I did explain about this already, the concept. Centripetal force is actually the resultant force. Yeah, resultant force from existing force. Okay, the resultant force MAC is actually the centripetal force. Okay. Centripetal force is the resultant force. Remember that. So, back to our questions here. Where can we find our resultant force for this free body diagram? Where can we find the resultant force? Yeah? Where can we find the resultant force? Where is the acceleration? Where is the acceleration? The acceleration in the x component or in the y component? The acceleration is in the x component. It's in the x component. It's not in the y component. Y component, resultant force is 0. X component has the resultant force. So for our case here, our resultant force is on the x component. So our resultant force, our centripetal force is in the x component. So it is also the, in other words, it is the centripetal force. It is a centripetal force. Our resultant force is in the x component because it has the acceleration. So our resultant force on this object, on the ball, is actually the centripetal force. It's actually this one. Okay. So or you use MAC also can. So how to find the resultant force for C? Question C. Let's do it. So for question C, the resultant force on the ball only exists in the x component. Only exists in the x component. And it is also the FC itself. It's also the centripetal force itself. But we don't have the AC. So we have to depend on the left hand side. We cannot use the right hand side. We can only use the left hand side. Okay? So the resultant force on the ball is the resultant force in the x component. So which is T1 cosine 30 plus T2 cosine 30. So let us find it. So this is 35 cosine 30 plus what? Plus 8.71 cosine 30. So what's the answer? Okay, the answer is 37.85 Newton. That's the answer. 37.85 Newton. Is it correct? Yeah, that's correct. Yeah, 37.88. Almost the same lah. Okay. So it's correct already. That's the resultant force. That is also the centripetal force. That also is equal to MAC. And that is also equal to mv squared over r. So from here we can, once we know the resultant force, we can find the centripetal force. We can find AC also, centripetal acceleration. We can find the speed of the ball also, the linear speed of the ball also, moving in the circle. We can also what? There's so many formula. We can even find mr omega square. We can find the omega angular speed. And then some more from omega, we can find omega equal to 2 pi f some more. Even 2 pi over period. So see, so many things you can find. From omega, you can find frequency some more. You can find period some more. Period of the ball rotating, how long it takes to complete one revolution. Frequency is how many revolutions it makes in 1 second. Yeah. Omega, V, all this you can find from this value. Yeah. Okay, let's what is the speed? see now the question asks to find the speed, which is the V. Which is the V. Okay, predicted. So can we find the V? Of course. Yeah. So let's do it. Let's find the V. Yeah. Let's find the V. Let's find the V. Yeah. Boring. Let's find the V. So the resultant, so we know that the resultant force in x component is actually the centripetal force, equal to MAC or MV squared over R. Okay, and just now the centripetal force we get is 37. Oops, sorry, what is this? 37.85. Okay, so 37.85. What is the mass again? The mass is 1.34. 1.34 times V. What is the R? What is the R? We haven't get the R yet. You see that? So this one we need to use Pythagoras theorem. This we know the triangle is a equilateral triangle. So let's find out the R first. This is the R. Look at here. This is the R. This one is the R. This is the R. Understand? This is the R. The R from the ball to the center of the circle. This is the R. So to find that R is this one. Maybe you should draw this one, the triangle again. Yeah, this is our triangle. So our R is this one. This is our R. Okay, this is our R, isn't it? The center is here, the ball is here, right? Isn't it? This is our ball here. So this is the R we need to find. We know that the sides is 1.7 each. Equilateral triangle. So this is 1. We know that it's 1.7, this 1.7, and it's 1.7. However, we need to divide into 2. So this one is what? Let's find out. Yeah, 1.7 divided by 2 is 0.85. 0.85. So we can find this is 90 degree. Okay, here is 90 degree. So can we find R? Easy peasy. Yeah, easy peasy. So R is just take the 1.7 square minus the 0.85 square. Okay, so what's the answer? What's the answer? Yeah, yes, the answer is 1.4722 meter. So that's the length. So we got the R already. The R. So we just substitute into here 1.4722, and that's the V we want to find. Let's find out. Okay, so we got the answer already. Yeah, we got the answer is 6.45 meter per second. That's correct. Is that correct? Yes, that's correct. 6.45 meter per second. That's correct. Okay, that's the speed. So like that lah. Very easy. Yeah. Okay, so that's all for this question. Bye.